So we're going to use this powers chart to help us solve exponential equations. So at the top of the next page, you would like to highlight an exponential equation is an equation that contains a power where the variable is. So you're going to solve something like 3 to the x equals 81. On your powers chart, you would say, well, is there any power with a base of 3 that equals 81? Absolutely, it's going to be 4. So the answer to this question is just 4. One of the strategies that we're going to use is we're going to say, if I can write the number with the same base, if I can write 81 as 3 to the 4, and this is 3 to the x, if my bases are the same, it's pretty obvious that the exponents would have to be the same if they're equal. So therefore, x would have to equal 4. So this is going to be our goal without calculator. We're going to look at the numbers. We're going to use all of our exponent laws, and our goal is to get one power on one side and one power on the other side with the same base. So in this question, we've got 4 and we've got 256. Maybe I'll go steal this. Go and steal my powers chart. First of all, is it all together? There it is. Off to the side, a little bit smaller. So for part A, well, obviously 4 could be in a base of 4. 4 is also in a base of 2. Is 256 in the base of 4? Yes. It is also in the base of 2. So what we're going to do is, step 1, we're going to change that 256, because it is 4 to the exponent 4, we're going to change it to 4 to the exponent 4. And now we're very close, but our goal is that on this side, we have 4 to something, which we already do, but we also want this side as 4 to an exponent. And if we can get both sides as a single power with the same base, then the exponents have to be equal. How do I move? Right? Basically what I want to do is I want to take this and move it to my numerator. How do I do that? What exponent law does that? Our negative exponent law says if you have a negative exponent, you can move it from numerator to denominator or denominator to numerator. It just switches where it is. And at this point, just by observation, this is not a mathematical step, so I'm going to go so x equals negative 4. Because right now, we have nothing that we know how to do mathematically to get rid of these 4's on the bottom, other than just observation. It has to be obvious that if 4 to the x equals 4 to the negative 4, that then what's x? It's obvious that x is equal to negative 4. So we're really going to use a lot of exponent laws from previous years. So in B, we have 27 and we have 9. So often you start with a smaller one, just like we did in example A. We looked at 4 and noticed in my powers chart 256 was in the same column as 4. But now, in part B, if I look at 9, oh, I lost number 9. There it is. If I look at 9, 27 is not in that powers chart. Yes. Oh, I have to be 81. But 27 is not in our column with 9s. So then in a question like this with 27, 9, is there any column that includes both 9 and 27? Yeah, our column of 3. Because 9 is 3 squared and 27 is 3 cubed. So this is why you need to have your powers chart memorized. Because when you get a question like part B, you need to recognize the numbers of 27 and 9 as both being powers of 3. So for 27, I'm going to write 27. I'm going to replace it with a set of brackets as 3 cubed. I would still have an exponent of x on the outside because I had 27 to the x. I'm going to replace my 9 with brackets as 3 squared, and I would still have 2x minus 1. And now our exponent laws from grade 9 really come into effect. What was the law when you had an exponent to an exponent? Because that's what we have here. An exponent to another exponent. Do we add, multiply, divide, guess? What's the strategy you usually use? Okay, so here we would get 3 to the 3x if I multiplied. And here, if I multiplied, I would get 3 to the 4x minus 2. And this was our goal. We have a single power on both sides with the same base. So I take out a different color and I go, so does it make sense that the 3x would have to equal the 4x minus 2? If they're going to be equal, the exponents would have to be equal. I'm going to combine my x's on this side. I'm going to move my 2 to this side. And we get x is equal to 2. Circle questions 3, 4, 5, and 6.